How do temperature scales work in thermodynamics? Imagine trying to compare how hot or cold different things are without a common language. That's where temperature scales come in, giving us a way to measure and compare thermal states. Temperature scales assign numbers to the warmth or coldness of objects based on how fast their particles move. When particles move faster, the temperature is higher. When they slow down, it's lower. To set up a scale, scientists pick two fixed points that everyone agrees on. Usually, these are the freezing point and boiling point of water at standard atmospheric pressure. The Celsius scale is one of the most familiar. It sets the freezing point of water at 0 degrees Celsius and the boiling point at 100 degrees Celsius. The space between these points is divided into 100 equal parts called degrees Celsius. This makes it easy to measure temperatures in everyday life. Then there is the Fahrenheit scale, which is mainly used in the United States. It sets water's freezing point at 32 degrees Fahrenheit and boiling at 212 degrees Fahrenheit. The interval between these points is divided into 180 parts. This scale was designed so that it's practical for daily activities and weather reports. The Kelvin scale is different because it starts at absolute zero, which is the coldest possible temperature where particles stop moving. Absolute zero is exactly 0 Kelvin. Each Kelvin degree is the same size as a Celsius degree, but since it begins at minus 273.15 degrees Celsius, it's used mainly in scientific work. It helps scientists understand energy and heat transfer better because it relates directly to the physical properties of matter. The zeroth law of thermodynamics supports temperature measurement. It states that if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This principle makes temperature a reliable and consistent property for comparing thermal states. You can convert between these scales with simple formulas. To change Celsius to Fahrenheit, multiply the Celsius temperature by 9 and then divide by 5, then add 32. To convert Celsius to Kelvin, just add 273.15. Thermometers measure temperature by observing a property that changes predictably with temperature. For example, the volume of a liquid like mercury or alcohol expands as it gets hotter. Electrical resistance or infrared radiation can also be used. When the thermometer reaches thermal equilibrium with the object, the change in the physical property tells us the temperature on the chosen scale. Using the Kelvin scale in thermodynamics is especially important because it starts at absolute zero. This 0 point makes calculations involving energy and heat transfer more straightforward. It also helps in understanding how engines work and how heat moves from one place to another. In the end, temperature scales work by setting fixed reference points and assigning numbers based on how fast particles move. These scales give us a clear way to measure, compare, and understand thermal energy in everything around us.